All right, remember the properties of a rhombus is that it has all the properties of a parallelogram: opposite sides parallel and congruent, opposite angles congruent, consecutive angles are supplementary, the diagonals will bisect each other, but also in a rhombus we have four congruent sides. The diagonals not only bisect each other, but they're also perpendicular, and your diagonals will bisect your angles. So if you look at number 21, if we see we have 36 degrees here, we can go ahead and make the angle beside it 36 because the diagonal bisects it. And then 36 plus 36 means this entire angle K is 72 degrees. Because it's a parallelogram, opposite angles are congruent, we can make each of these angles 36 degrees, and we know angle M is also 72 degrees. Then we can go further, and we know consecutive angles are actually going to be supplementary, so I can do 180 minus 72, which is 108 degrees. So angle L is 108 degrees, and angle J is 108 degrees. Now, because the diagonals bisect each angle, I can do 108 divided by 2 to get 54 degrees for each of the little angles. Now, because the diagonals are perpendicular, everything in the middle is 90 degrees. So when it asks for JKL, JKL is the entire angle 36 plus 36, which is 72 degrees. Then MLK, MLK is this entire angle, 54 plus 54 is 108 degrees. Then JMK, JMK is going to be my part right here, 36 degrees. MJL, MJL will be the part on the side, 54 degrees. And then KNL, KNL, since they're perpendicular, is 90 degrees. On number 22, you're using the same rhombus. Let me try to draw it. It's not going to be lovely. We've got J, K, L, M, and then we've got N in the middle. It tells me that MN is equal to 20, so that means NK will also be 20. JL, my entire diagonal is 26, so each part will be 13. We're looking for JK, which is going to be the side of the rhombus. If we find JK, we find KL, LM, MJ because they're all congruent. Now we know that our diagonals are perpendicular, so all of these are right angles. So let's do A squared plus B squared is equal to C squared, or 169 plus 400. Now let's take the square root and let's round to 1 decimal place, and we'll get 23 9/10 for JK. That means KL, LM, and MJ are also 23 9/10. Okay, looking at the next one, still dealing with a rhombus. Remember that your diagonals bisect your angles. So that tells me that 9x minus 43 and 5x plus 1 are equal to each other. 9x minus 43 is equal to 5x plus 1. Let's move the 5x to the other side by subtracting it. 9 minus 5 is 4. These two will cancel out, giving me 1. Now let's add 43 to both sides. 1 plus 43 is 44. And then we'll divide both sides by 4 to get x equals 11. If we plug this in, we'll have 5 times 11 plus 1, or 55 plus 1, which is 56 degrees. So each part is 56 degrees. If you add those together, the entire angle is going to be 112 degrees. So if we're finding SVU, which is this entire angle at the bottom, if STU is 112 degrees, then the measure of SVU is also 112 degrees. On number 24, we're told that AD is 4x plus 2. We're told that DC is 7x minus 13. And BD, which is my diagonal, is 34. So that'll be 17 and 17 since they bisect. We're looking for AE. All right, don't forget all of these are right angles. So let's find out the lengths of our sides, and then we can actually use the Pythagorean theorem to find AE, which is right here. So in a rhombus, all sides are congruent. So I can do 4x plus 2 is equal to 7x minus 13. Let's subtract 4x from both sides, and we'll get 2 is equal to 3x minus 13. Add 13 to both sides, and we'll get 15 equals 3x, so x equals 5. Now, if x equals 5, 4 times 5 is 20, plus 2 is 22. So each side here should be 22 units long. If I want to find AE, that's one of the legs of my right triangle, I'll do a squared plus b squared is equal to c squared. Okay, so let's work that out. We've got 17 squared, which is equal to 289. Then we've got 22 squared, which is equal to 484. Now subtract that 289 from both sides, and we'll get x squared is equal to 195. Take the square root, and you'll get x is equal to 14. Okay, and that's going to be AE. So AE is equal to 14 units. Number 25, you have a square. So a square has all the properties of a rhombus, a rectangle, and a parallelogram. So it's a pretty busy shape. All right, so we're looking for all the angle measures. I know that each individual angle is 90 degrees. Okay, and I know that my diagonal will bisect my angles, so each of these smaller angles will be 45 degrees. Okay, and I know my diagonals are perpendicular, so all the angles on the inside are 90 degrees. So when we find the measure of WXY, WXY is this entire angle, which is 90 degrees. Then XZY, here is XZY, is going to be my bisected angle, which is 45 degrees. YXZ, okay, here's YXZ, another bisected angle at 45 degrees. WRZ, WRZ is going to be one of my inside angles because they're perpendicular, is 90 degrees. And XWY, XWY, a bisected angle at 45 degrees. Using WXYZ, and my two diagonals, this will be R, tells me WY, which is my diagonal here, is 32, so we got 16 and 16. Now, in a square, diagonals bisect each other, but they're also congruent, so each part is going to be 16. And we're looking for XY, which is one of our sides. Now don't forget, diagonals are perpendicular in the rhombus and in the square. So I've got a squared plus b squared equals c squared. If we're looking for WX, we're looking for this side, or XY, excuse me. So we've got our legs, 16 squared plus 16 squared equals c squared. Okay, let's add these two together, and we'll get 512. Now take the square root, and we'll get c is 22 and 6/10. If c is 22 and 6/10, then xy is 22 and 6/10. So is yz, zw, and wx. Okay, now let's look at the next one. We're at number 27, so we're moving on to trapezoids. If you remember, a regular trapezoid has one pair of opposite sides that are parallel, and those are your bases. Consecutive angles that share a leg are supplementary. So if you look at this one, P and S share a leg. So I can do 180 minus 104, which is 76 degrees. So that means angle S is 76 degrees. Now Q and R also share a leg, so I can do 180 minus 41, which is 139 degrees. So that means angle Q is 139 degrees. Number 28 is an isosceles trapezoid. So in an isosceles trapezoid, you still have consecutive angles that share a leg, supplementary, but now we have congruent diagonals. The legs, which are your non-congruent or parallel sides, they're congruent. Your base angles are congruent, and your opposite angles are supplementary. Okay? So with that being said, I can do 180 minus 117, which is 63. So that's going to be angle E, and because base angles are congruent, angle F is also 63. So E and F are both 63 degrees. Now to find angle G, it's going to be congruent to angle H because base angles are congruent. Number 29, we have just a regular trapezoid. This is not a isosceles. So if you'll notice, these are consecutive angles that share a leg, so they should be supplementary. 8x minus 2 plus 5x plus 26 should equal 180. Take your 8 and your 5 and add those together. Take your negative 2 and your 26 and add those together. And now let's solve for x. Subtract 24 from both sides, and you'll get 13x is 156. Divide both sides by 13 to get x equals 12. We're looking for angle H, so the measure of angle H is going to be 8 times x, which we now know to be 12, minus 2, or 96 minus 2, which is going to be 94 degrees. Now on number 30, this is isosceles, so these are base angles, and I know base angles are congruent. So 8x minus 23 is equal to 6x plus 11. Subtract that 6x from both sides, and you get 2x minus 23 is equal to 11. Add 23 to both sides to get 2x equals 34. So x is equal to 17. So if we're looking for angle M, I know M and J are actually going to be supplementary. So let's find out what J is. So to find the measure of angle J, we'll do 8 times 17 minus 23. So 8 times 17 is 136, minus 23 is 113 degrees. So this angle right here is 113 degrees. It will be supplementary with angle M. So to find the measure of angle M, we'll do 180 degrees minus 113 degrees, which is 67 degrees.